So in this video, we're going to be looking at predicates and quantifiers in discrete math. So let's start off with the idea of a predicate. A predicate is a statement that depends on one or more variables and becomes a true or false proposition only after you specify values for those variables. So let's look at a predicate here. We have p of x, and you can see our variable here, it is x, and p of x can become true or false once x is given a value. I like to think of predicates as templates for proposition. So let's look at an actual example. Let's say that our domain is all integers, which in discrete math and logic is represented by z. So let's say for our p of x, x must be greater than 0, right, for our predicate. Then p of 3 is going to be true, right, since it's greater than 0. And if we have -2 for x, then it must be false. So that's just the rough idea of a predicate. Okay, so now let's look at quantifiers. Before we get into the idea of a quantifier, we have to know what the domain is. So domain is a set of all possible values that the variables in a predicate are allowed to take. This is also known as the universe of discourse. Okay, so now that we know what the domain is, let's go into actual quantifiers. So a quantifier is a logical symbol that tells us how many elements in the domain of a predicate applies to. So here, this symbol on the left here represents all, and this symbol on the right represents at least one. So these symbols are, what they basically do is they turn predicates into propositions. So we're going to be looking at this in further problems. Before we move on to translations, it's important to know that the symbol on the left is known as the universal quantifier. And the symbol on the right is known as the existential quantifier. Okay, so now since we know what these symbols' names are, let's move on to translations. So I've written down the domain and the predicate here, and we're trying to translate this. So the question states this: every book has a title. Since we're looking at the word every, this means we're looking at the universal quantifier. And so we would use universal quantifier like this. And since our predicate is tx, x is a title, we're going to be having the universal quantifier for tx. The reason we're doing this is because it says that every book has a title. So therefore, this should be our answer. Question number 2 states this: some cars are electric. So when we say some, this means that at least one, but not all, right? At least one. So then, therefore, we're going to be using the existential quantifier. So the domain, again, is all cars, and our predicate is going to be x is electric. So it's going to look like this. So that's it. I think there's a little bit too much of a gap in between them, but if you write them closer together, it'll be better. Sorry about that. And for question 3, it states this: there exists a student who solved the problem. Again, there exists means that there is at least one, right? And so the domain is all students, and therefore predicate is x solved the problem. So it's going to look like this. Just like before, we're going to have our existential quantifier, and we're going to have this. Okay? So that's it. Now question 4 is a little bit different and states this: all students in the class have a friend who likes pizza. So our domain in this case is all students in the class. And so we can create 2 predicates here. Our first predicate has both x and y, where y is a friend of x. And ly means y likes pizza. So how can we format this together to make sense? So it starts off like this: all students in the class, right? So we're looking at for all students belonging to the class, right? And have a friend who likes pizza. So that means there exists some y, right? Where y is a friend of x, right? Y is a friend of x. And y likes pizza, right? So this is basically all it is to this one. So I hope this video helped, and thank you for watching.